Hi everyone, today we're going to be talking about solving literal equations, so go ahead and title your paper, this set of notes, Solving Literal Equations. We are going to be using the same process as we do in when we isolate a variable in an algebraic equation, just like we have it in our 1, 2-step, and 3-step equations. Instead of manipulating our numbers, they're all going to be letters. So I'm going to go ahead and write that down. So we are going to use the same process to isolate a variable in an algebraic expression. Sorry, let's actually say equation on that. Okay, with one variable. And the operations that we used to do that, the first one that we had to use was addition or subtraction. You want to get rid of addition or subtraction first. And then you also want to get multiplication. Then your next step is to get rid of multiplication and division. Okay. So those are our steps, but instead of using numbers, I will be showing you guys they're going to actually be variables. So for our first example here, we are going to solve E equals I times R, and we're going to solve for R. So you guys will always be told a variable to actually solve for. In this case, it's our R. So just like our regular equations, now we have no numbers. You could pretend that these are numbers, and you can make them numbers if you wanted to. But so you want to pick which side your R is, the variable you're trying to solve for. Mine's on my right side. I don't have anything else extra that's not touching the R, so I actually have to skip the adding and subtracting step. So now I have R that's being multiplied by I, so in order to get rid of multiplication, it's division. So we're going to divide both sides by R, and then when I divide both sides by R, I end up leaving, this is what's different, is that since they're not like terms, these I's and the E's do not get to combine. These I's do divide out just like they normally would, and then now we're equal to R. So we did get R by itself, and we leave it as is. Okay, so now let's go ahead and actually do a different example where we have, let's see here. Let's do area equals 1/2 base times height. Hopefully you know that is an area of a triangle. And we are going to go ahead and solve for h. Okay, so we're going to try and get h by itself. So I'm going to go ahead and rewrite my equation over here just so we can have more space to work with. So some of you might have also seen this equation written as this. So the reason you have area equals 1 times b times h, so this is just b times h over 2. This is actually the same equation, we just multiplied that 1 there. So either way, I'm going to show you guys either way equation that you're used to using, and we're going to go through this. So get rid of we have all multiplication here, so we're going to be using a lot of division. And then this is our division, so we're going to use multiplication to get out of our fraction first. So I'm going to go ahead and multiply by 2 to get out of that denominator just like we would in our algebraic expressions. And then 1 times b times h is what that says. So this is all being multiplied. 1 times b is just going to be b. So the only thing I have left over is h being multiplied by b. So now I'm going to divide both sides by b. And now I'm left with 2a divided by b equals h. We got h by itself, we're done. See how I can't combine these again because they don't have like terms? Now over here, it's the same thing. We're going to multiply by 2. So now I get 2a equals b times h. Oh, and right here already, that 1 again, remember 1 times b, or 1 times 5 is 5, 1 times 100 is 100, so it's always whatever 1 times itself is going to be itself. So now our last step is to divide by b, and again, I cannot combine that a and b, so we just rewrite it as it is, and that is our final solution either way. Okay, and then let's just do our last example. So this one has a little bit of adding and subtracting in it. So right now we're going to solve P equals 2 times the length, so L plus 2 times W. And we're going to solve for W. Okay, so this one actually has addition and subtraction. So we have W over here. So the thing that's not touching the W is this 2L. And what's cool is that since this is a whole term with together, we actually get to subtract this whole term together. You can do this all in one step there. So now I have P minus 2L equals a positive 2W. So now we are here in our equation, P minus 2L equals 2W. We still have to get W by itself, and so the number that's being multiplied by W is 2. So we're going to divide by 2 on both sides, and now we're left with our final answer, which is P minus 2L divided by 2 equals W. Yeah, I'm okay if you guys leave your answer here, but if you don't like that, you want to break it down a little bit further, just make sure that you have two terms here. So that means that we are going to have this being divided by two separate terms. So let me show you another way you could rewrite this. If you have P divided by 2, we can't simplify anything there, P divided by 2, minus our 2L divided by 2 equals W. So what can we actually simplify here? Well, this divides out, and we are left with P divided by 2, and then still minus, but we have just an L equals W. So either answer I would be okay with. All right, you guys, that is the notes for today. I will see you in the next class.